Hello, so we're looking at question 8.11, solve the problem illustrated in example 8.9 using the Henderson-Hasselbalch equation. So let's go to example 8.9. That is this one, in which they tell us that they want us to calculate the pH of a buffer solution. They tell us that the acetic acid and sodium acetate concentrations are both the same. And then they tell us the equilibrium constant, Ka, for the acetic acid is this amount. So the Henderson-Hasselbalch equation is this, and they tell us they want the pH, and they just told us our Ka, and they told us the concentration of our conjugate base and our weak acid. So all we have to do is plug in this value, this value, this value, crunch the numbers, and we can get the pH, our answer. Okay, so luckily here they told us that the acetic acid and the sodium acetate concentrations are the same. So no matter which one's which, you're going to put this value both here and here. But just to identify them, the acetic acid is the acid. And the sodium acetate is the conjugate base. Okay, so they want the pH. So pKa is going to be, I'm going to go ahead and say P is the negative log of something, right? So let's go ahead and say negative log of the Ka, which in this case is 1.8 times 10 to the negative fifth. And close that parenthesis. Now we bring down our plus and our log of our fraction. And in this case, both numerator and denominator are going to get this concentration, 1.0 times 10 to the negative 1 molarity. So pH equals, I'm going to go ahead and bring this down, negative log of 1.8 times 10 to the negative fifth. Oops, sorry, wasn't on camera. Anything divided by itself is just a 1, so that's plus log of 1. The log of 1, let's think about that. If we don't see anything here, then that's base 10. So 10 raised to what power equals 1? 10 raised to the 0 power equals 1. So essentially this is 0. So in other words, we've got pH equals negative log of our number plus 0. So that means what we really have is pH equals negative log